Hi. In this video, we will learn about the NPV function in Excel.
We can use the NPV function in Excel to calculate the net present value. The syntax of NPV is you got the rate, that is the discount rate over one period, and then we give the values of the cash flows one by one. Or you can give a range, as we'll see in the example. We use NPV in capital budgeting, where we want to determine whether to accept or reject a project. Here the goal is to maximize the profitability of the company and to enhance shareholder value. And the decision rule we use is if the project has a positive NPV, it increases the value of the company, so we can accept it. If the project has a negative NPV, it decreases the value of the company, then we reject it. And if the project has an NPV of 0, it basically keeps the value of the company unchanged. So it doesn't really add value or reduce the value of the company. For net present value calculations, what we do is we use this formula, future value equals present value into 1 plus r to the power n to calculate present value. So here if we rearrange this, the present value, so present value will be equal to future value divided by 1 plus r to the power n. So that's how we discount each of these cash flows to arrive at the net present value. So the general formula is NPV equals minus C0. So this is the initial investment. We are reducing that. And then each of the cash flows we have to divide that by 1 plus r to the power n to discount it back to the present value. So these are future cash flows. So depending on the time it occurs, we divide by 1 plus r to the power n, where n is the time period. So it can be the first year, second year, and so on. So let's look at an example. We have a company having a discount rate of 12%. So the 12% discount rate is actually the weighted average cost of capital of this company. And we have the cash flows. At time 0, we have the initial investment of 1 million. So it's a negative cash flow. And from year 1, we have these cash flows onwards until year 5. So we can calculate the present value of these cash flows using first principles. So what we do is we take the cash flow and divide that by 1 plus r, as it is the 1, that is the 1 plus the interest rate, and to the power n. So we use the hat sign here, and then n is the 0 in this situation. It will go from 0 to 1, 2, 3, 4, 5 like that. And when we are going to copy it across, we will need to fix the interest rate or the discount rate here. So we can use F4 to fix that. And then I can enter this and I will copy it across. So the time 0 cash flow is the present cash flow at time 0, and it's not really discounted. So even if we use the formula, because this becomes 0, it's not really discounted, it becomes 1, and this is the same value we get. But from year 1, we get the cash flows discounted. So that's why the 250 is reduced to 223,214 in present value terms. So it continues to discount the cash flows, and as you can see, the 700,000 is just 397,199 in present value terms. So this is the total of the present value. So if you want to do the net present value in the DCF or the discount or the discounted cash flow method, we can just sum all of these cash flows to arrive at the net present value. We can sum all these cash flows like this, and we arrive at 676,492. That is the net present value in discounted cash flow terms in when we do the first principles calculation for discounting. So we can actually use, so now we will see how we can use the NPV function to calculate this. So let's do the NPV function. I can write here NPV, and then I can use the rate from here, and then I need to give the cash flows, and I close the bracket and enter, and I get 604,000 versus the actual value of 676,000 when I calculate on DCF methods. So this is less. The reason is NPV function assumes that the cash flows, that the first cash flow is one period from now. So we need to exclude the first cash flow or the initial investment from the NPV function. So otherwise the calculation is wrong, because NPV assumes that cash flows are occurring 1 year from now and onwards. So here, so it's basically assuming this initial cash flow will occur in year 1. So that's why we get a different value. So what we need to do here is we need to change the range inside the NPV function to just start from year 1 onwards. And we can add the initial cash flow, the initial investment, separately into the formula like this. So it's outside the NPV function. Then we get the same result. So now our NPV function is correct. So we need to be careful. We need to exclude the initial cash flow at time 0 from the NPV function's cash flow range, and then add it separately into the formula.
Thanks for watching.